Hello everyone. Today I'm here to talk about some more changes to the mixer code and some more improvements that are going on to making the mixer code better. To start out, I'll talk about this smoothing motor mix, which is what all this work is based on. And I've currently been working with Tyler Corleone, an Italian guy, and he's been really awesome. He's come up with this code idea, and we've just been bouncing ideas off of each other, getting things better, and we've had some cool stuff come out of it, but this is primarily his work. It works really well actually, and yeah, let's just go through and I'll review kind of what it does and all that sort of stuff. So these two graphs here, you see the graphs on the left and the graphs on the right. The graph on the right is the torque that the motors are producing at essentially maximum torque. So maximum torque would be you have motors at full throttle and motors at zero throttle, and that's the max torque. So you'll see 100% is this flat spot, and below that's not. And then this graph is a graph of the motor output. So we have throttle along here, so as you increase the throttle when air mode is off, eventually you hit a point where you're, if in case you didn't know this, in the current code, if air mode is disabled, at a certain point, air mode turns on. When your throttle's above 50%, it has that air mode type handling. Anyways, this is showing how your motor outputs would act. In motor mix delta, this is looking at two motors. So we have throttle, which is where you've moved your throttle on your controller, and then motor mix delta is the difference between two motors. So if the difference between two motors is, this shows all the way up to 50% difference, from 0 here up to 50%. You can see that when air mode is off, the torque that you're able to produce is shrunk. Like, this is the percentage of the total torque that you should be getting, and you can see you're missing a bit of that torque. And this is the original code, these first two. This is what it's like when air mode's off. With this smoothed out code, when air mode's turned off, you can see the motor output. It's actually smooth along here, and it's less abrupt. The air mode difference is less abrupt. Obviously you get a bit less air mode power on the new code, but it's a smoother transition here. And as you can see, there's some sharp lines, like right up here there's a flat surface up there. It's just sharp lines. Here it's all smooth. You don't see any sharp. And this is air mode turned off for this, if you're using this air mode 2.0 kind of version. I'll get into that a bit later. Anyways, here's another graph. So this was all air mode off, and this is more adjustable than what this shows. I'll get into that later as well. But here's the code with air mode on. So this is original. The top one is original air mode, what we've had for years, literally. This code hasn't been touched in years, and you can look at these sharp edges. Nice and flat here, sharp line up, and then flat across the top. And you see this flat face here, another face here, another face here. You still get your full torque that you want, that your quad wants you to have. You still get full torque. However, your motor output is jagged. Here, if you take a look at this, it's all one smooth face. It's like, this is continuous. This is multiple flat faces. There's one here, and one here. This is all one smooth face, and you still get all the torque that your PID controller wants when you use the smooth. And here we have air mode smooth 2. We're going to call it air mode V2. I haven't tested this a ton, but it's obviously quite interesting in how different the motor output looks here. But yeah, this air mode V2 in theory can still give you all the torque that you need. So if I come through here, here's some more images of how this code is able to smooth out things. And you'll notice that this is air mode 50%. Because in the code we can actually tell you how much air mode we want. So in the code now, so this is the older code. This is the newer stuff, and in the newer code, there really isn't a way to turn off air mode. It doesn't make a whole lot of sense to do that. So instead, we're able to actually change the air mode strength. Anyways, the default, I'll show you what the defaults are better. But the default will be 50% air mode when you turn air mode off, which means, it essentially means that if you bounce on the ground at 50%, with 50% air mode and you bounce off the ground, when you're at 0 throttle, the most that your motors can output is 50%. Whereas with whereas here it allows even less than that. But anyways, you can just really see the differences between these two very similar things with the new code, which is really smooth, versus the old code that was quite jagged. It's quite interesting. Yeah, so here's the smooth mixer, and yeah, you can see it just really smooths things out. Something cool that I ran into is actually today, Boris B, the guy that started EmuFlight, he actually came in here and commented on this code. So looks like Boris is kind of back a little bit. But yeah, so this is really how the code's able to smooth things. And what's really cool is you can see from all these graphs that the torque, which is really, if the quad wants a torque, which is a difference in motors, if it wants a certain difference in motors, how does it get that difference? Well, with all these different air mode versions, you technically get that full difference in air mode, which is really kind of cool. You get that full motor torque, so your quad doesn't have less authority by using this, but it has a smooth transition. The old air mode's jagged, these other two air modes are smooth. And there's something different and interesting about the air mode smooth version 2, or we just call this air mode, and this will be air mode version 2 because it's quite different, as you can see, in how it's modulating the motors. Anyways, I'll jump into a little bit of that more here. So the new bits of code that you've got to play with is this air mode min authority and max authority. And min authority is your air mode strength at 0 throttle, and the air mode max authority is your air mode strength at full throttle. So by default, the air mode strength at min throttle is 50%, so by default you get 50% on the ground, and if you're at full throttle you get full air mode strength, which the old air mode code, if air mode was turned off, and this is only when air mode's turned off, not when it's turned on, you would get 50%, well, you'd get air mode off, which is a bit different than 50% air mode strength, but at full throttle you'd get full air mode strength. So you can play with that, to whatever extent you would like, try and get that working well. But and if you wanted to, you could even set your air mode strengths both, air mode authority. You could set your air mode min authority and max authority to say 50, and then your maximum motor difference is only 50%. I've played around with that a little bit, and that can be kind of cool, because if you really want to prioritize throttle, at high throttle, maybe you're a racer and you want to prioritize throttle. If you look at some logs, you'll see that at full throttle your motors are bouncing around a whole lot. Now if you set your max authority a lot lower, then when you're at full throttle, your motors wouldn't be able to bounce around as much. And since you're at a higher throttle, you may not really need as much air mode because you just have more authority over your props and motors now that you're at a higher throttle. So there's that. There's also predictive air mode. So what predictive air mode is it's a way of giving you full air mode strength some of the time and less air mode strength other parts of the time. So by that, what I really mean is, say you crash into something, and your quad freaks out, or you bounce on the ground and your quad freaks out. Like if you have a little whoop, you're going under a table, you hit a leg and your quad freaks out, and then it bounces around and it just gets lost. The idea with predictive air mode is you can set a lower air mode authority, and then as you move your sticks, it increases your air mode authority. So when you're not moving your sticks, your motors aren't allowed to move as much. If you set your min and max to say 25, then your motors can only be a difference of 25% during parts of the flight where you're not moving your sticks. And once you start moving your sticks, the air mode authority will increase. Because you have this multiplier and it'll start boosting your air mode strength. And so if you set this high enough, you could essentially have pretty much full air mode strength the whole time. I played with it a little bit. I'm not entirely sure how I feel about it, but I think that could be cool for whoops. You crash into something, your quad doesn't freak out as much, you bounce off the ground, it doesn't react as much. And I have seen that, and it can work fairly well when you get it set up right. And lastly, there's this axis lock. I'm probably going to change the word multiplier here to strength at some point, but we have axis lock multiplier and axis lock hertz. These two things are kind of a new idea. Essentially, this alters your mixer so that as you move your sticks, the axes that you're not moving have less effect. So if you, for instance, do a quick roll, you're moving your roll stick a lot, and so pitch and yaw have less effect for the duration of your roll movement. Once you stop moving roll, you have that effect again. You have your pitch and yaw effect. And if you move pitch and yaw, then pitch and yaw will both have normal strength, but roll will have a lessened strength kind of thing going on. So this is an interesting way to kind of like do maneuvers, do flight stuff that, I've heard that, some of the guys testing it, they like how juicy they can get with this because they can do their maneuvers and you can really just flick one axis, whatever it is, and the other axes kind of don't do anything at that point. So it's kind of cool, it's something to play with. Axis lock, a lot of, I know some guys testing it that have really liked it. So that is something to play with. It's more like the axis that you're moving, the stick that you're moving, if you're moving pitch, then pitch is extra locked in. Not really extra, but the other axes are just no longer locked in. You move yaw, the other axis is kind of dulled down, and yaw's the one that's locked in. So kind of interesting, kind of cool, kind of neat. Yeah, you'll have to enable that. You just increase this value above 0. Same for the predictive air mode multiplier. Once you set that above 0 and air mode is turned off, that's when predictive air mode turns on. But yeah, so just set this above 0, set the axis lock hertz. Same with the air mode multiplier hertz. That's just a filter that's applied to the stick movement. And part of the reason we put a filter on there is so it doesn't just, overreact. And then as well, once you've stopped your move, it doesn't instantly lose the effect. So the effect's able to linger for a little bit. So you can play with different hertz. A lower hertz will act a bit different than a higher. You generally don't want to go super high with it. The default's 2. I've seen guys playing with 1 to 4, maybe up to 10. And then for the multiplier, I've seen people, generally less than 10, and they're perfectly happy with it. But this is in the OSD. The air mode strength stuff is not, but predictive air mode and the axis lock is in the OSD, so you can play with that. And lastly, I'm going to talk about air mode version 2. So before I get into that, something that is essential to making air mode version 2 work correctly is thrust linearization. And so to begin, this thrust linearization is different than the way that Betaflight or Silverware or anyone else has accomplished thrust linearization before. And we're doing it this way, and it's the only way that air mode version 2 can work. So you have thrust linearization, a value from 0 to 100. The higher you raise this value, the more effect that it'll have. And actually, I can come and take a look at it here. This is more stuff from Tyler. Yeah. And as he says, as he said in here, thrust linearization level, it just changes thrust linearization like stuff, but he expects values of 70 to 90 to be fairly normal. 70 or 75 for his tiny whip, that's what he's tested it on, and 85 to 95 for larger quads. Yeah, so high values for this will be wanted, but you can play with that, you can log it, you can see how things are flying. But here's the code again. Yeah, so we have thrust linearization level. Yeah, just play with it. You'll probably want higher values in the EmuFlight version or even silverware version, but it should be there. And then use throttle linearization. What this means is if you set throttle linearization to on, then it'll apply thrust linearization to your throttle. So that can actually be a way to help tune thrust linearization. And these are both in the OSD under your rate profiles. I want to move thrust linearization out of the rate profiles because it's more of a PID tuning thing, but throttle linearization is more of a rate thing. So I want this to go to the PID profiles, this to stay in rates, but for now this is in rate profiles. I didn't want to go through the effort of changing that because, yeah, just didn't want to mess around with that. But one way you could, theoretically tune it is if you're looking for a really linear throttle feel, you can keep messing with thrust linearization use throttle linearization set to on until you have a really linear throttle feel. And once that occurs, you know that your motor output is now linear. And then if you don't like that linear feel, you can turn this off. So that's just an idea for tuning this, or you can just play with values here until it flies the best. But yeah, so that's this thrust linearization, which is essential for airmode version 2. So in order to use airmode version 2, you have to turn it on and you have to have thrust linearization. If you don't have thrust linearization, then your airmode version 2 won't actually be applied because it just won't really work without thrust linearization being applied because of the way this math is working. Because the way that the math works for airmode version 2, and I should be able to show you a nice little graph a little bit if we go back here. Yeah, as you can see, there's the torque graph and the motor output graph. So with these graphs, with the air mode smooth or the new air mode, it's a nice linear, not linear, this is more linear, this is more of a smoothed output, this is a more jagged one, but you have the smooth output here, and this you have this odd sort of face. It looks a bit odd, and if you look here, I wonder if he has any more pictures. I can't remember. No, I think these are all that he has for the air mode smooth too. But anyhow, this first version is doing air mode the way we've always done it, where the torque, we base torque on difference in motor output, and we say that's torque. So if one motor is at 0, one's at 50, that's 50% torque. However, we know that's not entirely true because of the way that thrust works. Because for instance, from 50% throttle to 100% throttle, we might actually get more torque if one motor is at 50 and one motor is at 100 than we do when one motor is at 0 and one motor is at 50, just because of the non-linearities of torque coming off a motor. Because torque isn't linear to our motor RPMs. So anyhow, this code it's crucial that the motor output is linear. If the motor output not the motor output, thrust, because the motor output is fairly linear. That's how things work. But it's the thrust that needs to be linear. So this is really based on the fact that the thrust is linear rather than the torque. I mean the motor output. So this is based on the thrust being linear rather than the motor output. So that's why this one is crucial that the thrust linearization is applied. Because otherwise, if you have no thrust linearization and it tries to do what it's doing, the air mode will just be off and it'll not be good. But yeah, so this is an air mode that you can try out. It uses an interesting idea. This hasn't been tested a ton, so this air mode version 2, it might not stay. We just haven't had a ton of testing, but it's really interesting to use an air mode that uses, linear thrust outputs to give us that really nice torque, whereas these other ones have just done motor output based things. And yeah, so this should be really interesting to play with. I'd really like to see some people going out trying out thrust linearization, even throttle linearization, and seeing how they like the feel of a linear throttle or a normal throttle, the normal throttle feel, or a linearized throttle feel. Because really, when we apply thrust linearization, the way that it kicks the motor output to all the motors, it really alters it, and whatever linearization curve we put on our motor output to give us linear thrust, that'll affect our throttle. So in the code we actually have to make our thrust, the throttle that we're inputting to everything, we have to run the opposite of the thrust linearization curve. So, the thrust linearization curve will, give us more thrust at low throttles, whereas a normal curve gives us, just linear motor outputs. But yeah, so anyways, we have to run some code to get rid of the thrust linearization to modify throttle. And if you turn this on, it'll just no longer do that to the throttle, and throttle will just be applied like normal. So, like I've said, this can potentially be a useful way to find out how linear your thrust is. Just play with this until it just feels really linear. And if you do have a tiny whoop or something similar like that, and a way to measure thrust, you could mess with this until, 10% thrust is 10 grams, and 20% thrust is 20 grams, until you mess with it and find that your throttle's linear. That's actually what I heard that Tyler did, if I remember correctly, and that's how he came up with the 70 to 75 for a tiny whoop. But yeah, that's something that Tyler's come up with. So I don't take any credit whatsoever for this air mode version 2. I just did the predictive air mode and the axis lock. This new air mode stuff he's done, that's been all his idea. I've given him some input and feedback, but this is really all Tyler's idea, and it's just awesome. I mean, look at how smooth we get these motor outputs. This is, a pretty bland looking version of it. If we come over here, you can really see how smooth this code is able to really get your motor outputs to be, rather than a jagged, not curved. Yeah, you can get a curved output from Tyler's code, or a jagged output from, the normal Betaflight, motor output mixer. So this stuff's really cool. Yeah, I'm really excited to see what can become of it. We've already had quite a bit of testing on this code. The new stuff for, the testers is this air mode 2.0 or version 2, this thrust linearization and the throttle linearization. They've already been, at least some of them have already been testing some of this air mode authority stuff and this predictive air mode, as well as the axis lock, which a lot of people think is, there's been a few guys that have really liked the axis lock. Predictive air mode has been more here or there, so this might not see the light of day. We'll have to just see how that ends up working out. But yeah, the ability, yeah. So going over all the changes, just as a wrap up, we have the new air mode code, and that's just put into the new builds. If we turn air mode off, we have air mode min authority and max. That's air mode strength at 0 throttle and full throttle. And we have predictive air mode, which tries to give you full air mode strength as long as you're moving your sticks. The idea here is you can bump into walls or the ground and your quad won't freak out as much, because you'll have like air mode off when you bump into things, but you'll still have air mode strength when you move your sticks. So you can still be 0 throttle in the air doing flips, but then you can bounce, you hit the ground and your quad doesn't spaz out. Axis lock is, you move a stick in a certain direction. You move pitch, you move your pitch stick, so now roll and yaw are kind of ignored, or you move yaw and kind of pitch and roll are ignored, so it kind of locks the axis that you're moving. So I move pitch, and now my pitch is super locked, and yaw and roll are not very locked. And then aside from that, we have thrust linearization. That's thrust linear in Betaflight, and then we have throttle linearization, which applies the thrust linearization to your throttle essentially, and now your throttle will feel more linear. It won't feel the same, so you might not enjoy that, but give it a go. Then air mode V2, when you have air mode turned on and you have air mode version 2 enabled. Actually, do you need air mode on? No, I lied about needing air mode on. You do not. Even if air mode's off, you can have the air mode V2. So all this air mode stuff I've been telling you about, that can work with a V2 on or off, same as all the strength stuff. Yeah, so that's air mode version 2. You need thrust linearization to go give that a try, but I'd really like to see some reports of how the air mode V2 works compared to the just normal air mode. But remember, if you're going to use air mode V2, get some good thrust linearization levels first, then enable it. I think this is in the OSD. I'll need to check real quick. I don't remember all these things. Yeah, it's in the OSD under your rate profile. So you look at your rates. Thrust linear, throttle linear, and air mode 2.0. So yeah, you can play with these things. Get your throttle to feel linear. So if you turn on thrust linearization, you can get throttle to then feel linear, and then you can enable air mode 2.0. Yeah, really do with that what you will, but I really think this stuff has a lot of potential, and I'm really grateful for Tyler and the work that he's put into making it work. And all these wonderful graphs. It's really incredible what Tyler has accomplished. And right now he doesn't even have a drone that flies, and he's still helping me with some of this code and helping, update some stuff. So the code that I have written right now, that'll be changed a fair bit because Tyler wants to make some improvements to it, and I'm more than happy to let him because, as you can see, he knows his stuff. But yeah. Have a good one, everyone. Thanks for watching, and enjoy the new smooth air mode. Thanks for watching. Take care.